Hi there, welcome back. Today we are on solving equations, and this corresponds to lesson 4.1 in your Dynamic Math 10 workbook. And one of the key ideas in this lesson and this unit, one of the key ideas is that when you're solving equations, always do to one side what you do to the other. So here's an example, 3x equals 9. Maybe for some reason I want to add 5 to this side of the equation. I don't know why I'd want to, but let's say I did. Well, now it's no longer equal. To keep it equal, we would also want to add 5 to this side. So that's very key when solving all of these algebra. What you do to the left side, also do to the right side. Or here's another example. Maybe I would divide by 3 on this side. And then I would also have to divide by 3 on this side to keep it equal. So this is a very important principle to keep in mind. And then there's a second principle to keep in mind as well. Okay, and here it is. When solving equations, do the opposite operation or operations in reverse. So here's a sample problem. 2 times 4x plus 5 equals 18. So if we're trying to solve for x, we can think about what are the operations that are being done to x. So x is being multiplied by 4, and then 5 is added, and then we're multiplying by 2, and that gets us 18. So the operations are multiplying by 4, adding 5, multiplying by 2. And so if we follow this principle, do the opposite operations in reverse. So the very last thing that was done on this side was multiplying by 2. And I know that the opposite of multiplication is division. Divide by 2, divide by 2. 4x plus 5 equals 9. Equals. Okay, so now we're just left with, I'm going to give myself some more room. Okay, so now the very last thing that was done to 4x plus 5 was adding 5, and the reverse of adding 5 would be subtracting 5. And because it's an equation and I want to keep things equal, I'll do it to both sides. Minus 5 on this side, minus 5 on that side. 4x equals 4. That really means 4 times x, and the opposite of times, again, is divide. This time we'll divide by 4. And actually, at this point, you can probably just tell by inspection, or just by looking at the question what the answer is. Of course, x equals 1. So the two skills when solving equations: always do to one side what you do to the other. And then the other key skill, when solving equations, do the opposite operations in reverse order. We've basically undone everything that was done to the x. Okay, now let's try a few questions, from the lesson. So this is question 9 on page 103 in your workbook. And the question is 3x minus 3w minus 2 plus w equals 5 plus 7w minus 3. Okay, so here's what I'm thinking the first thing we're going to want to do is collect like terms. And by like terms, I mean we could group together these because they're both w's, terms with w in them. And then on this side of the equation, we could group together 5 and 3 because both 5 and 3 don't have w's. So this would simplify then to 2w minus 2. Does that make sense? If we have 4w minus 2. If we have 3w and then I add a w, that'll give us 4w's. Okay, and then on this side of the equation, I have 5, take away 3. That should leave us with 7 W's and 2 plus 2. Okay, so from here, the next thing to think about is, can we get all of the terms with W's, or both of the terms with W's in them, to one side of the equation, and the terms without the W's to the other side of the equation? Let's do that. So if I were to just take away this 4W here, okay, and then thinking back to those principles we looked over, if I'm going to take away 4W's on this side, to keep the equation equal, I'll also do it to this side. Okay, and now let's see if I can get this constant term to this side. Minus 2. Okay, so 2 minus 2 is 0, so they'll cancel. And then to keep the equation equal, I'll also minus 2 on the left-hand side. And that gives us minus 4 equals 3W. And that really means 3 times W. And the reverse of times is divide. And I could show it with the division symbol, or I could just write it like that. Remember, a fraction and a division statement are the same thing. So there we are. There's our final answer. W in this question is minus 4/3. Okay, here's another one. This is question 11. 2x minus 9 equals 9 minus 3x plus 2. Okay, so just like in the last question, we'll collect like terms if we can. On the left-hand side, I don't think we can simplify that anymore, but on the right-hand side, we have 9 plus 2. 9 and 2 gives us 11. Okay, 11 minus 3x. And so this is similar to the previous question. We want to get the terms with x on one side of the equation and the terms without x on the other side of the equation. So I've got options. I could either get rid of this positive 2x over here by minusing 2x, or, and then we would just have x's on this side of the equation, or the other option, I could add 3x, and that would cancel the x's on this side. Minus 3x plus 3x would be 0, and then I do it to this side as well. So that's a choice, and some students will prefer to do it one way and some the other way, and there's no right or wrong way. So 2x plus 3x gives us 5x. 5x minus 9 equals 11. Okay, and now maybe by inspection, maybe by just looking at it, you know what the value of x is. But let's keep doing algebra, because algebra is so wonderful. Okay, I want to get rid of this minus 9. And I know the opposite of minus 9 is plus 9. And then I'll also add 9 to the other side. So the 9's cancel. Sometimes it's also helpful to cross out the terms that disappear. So here the minus 9 disappears. And now we're left with 5x equals 20. And here, you probably can just tell by looking what x is. But let's, again, use algebra. 5 times x. If I want to get rid of 5 times x, I could divide by 5. 5 times x divided by 5. We're undoing the multiplication effectively. And then I'll do the same on this side. And I end up with x equals 4. So this is essentially the process for all of these questions. We're going to collect like terms, move terms with variables to one side, and move numbers, or sometimes we would say move the constants. These are the terms without letters, without variables in them, to the other side. So let's try question 13. 13 says 4x plus 4 equals 6x minus 2 minus 4x. Okay, so let's do the first step. We're going to collect like terms. I see here's a term with an x in it, 6 of them, and here's a term with an x in it, 4 or minus 4. Hopefully that makes sense to you, that if we're starting with 6 x's and then we take away 4 x's, we'll be left with 2 x's. Okay? And now move the terms with variables to one side. So right now we've got variables on this side of the equation, variables on that side of the equation. I know that the opposite of positive 2 is negative 2, so I could get rid of it on this side by subtracting 2 x's. They're gone. And then of course, to keep the equation equal, that important principle of algebra, what we do to one side of the equation we'll also want to do to the other side of the equation. Two x plus 4 equals minus 2. So this is great. The only side of the equation with variables is here on this side, the left side. And then we can look at our third step, move the numbers or the constant terms to the other side. So I want to move this positive 4. And what's the opposite of positive 4? Well, the opposite of positive 4 is minus 4. Two x, these cancel, equals minus 6. And then I'm going to divide by 2. Okay, let's carry on now. We're on to 4.1c. 4.1c. Oops. And this corresponds to page 105 in your workbook. And we're going to go through a few questions. So let's try question 1 first. Question 1 says 3 times x minus 1 equals 12. And you might just be able to guess by looking at it what x is. But it's helpful to do it algebraically too, I think. 3 times x minus 1 equals 12. And the key we mentioned was that we want to do the opposite operations in reverse in order to solve for x. So x, 1 has been subtracted, and then we've multiplied by 3. So this 3 is the last operation. It's on the outside, isn't it? And the opposite of multiplying is dividing. So we'll divide by 3. And I'll do it to this side as well. X minus 1 equals 4. And this, we can do this because we're doing the same operation to both sides. We know the equation is still equal. And 3 divided by 3 is just 1. So that effectively cancels out the 3 here. I guess we could say we're left with 1 times x minus 1 on this side. But 1 times anything is just anything. So we can just say that it's x minus 1. And then the reverse of minusing by 1 would be adding 1. And that leaves us with x equals 5. Okay, here's a slightly harder one. This is question 9. And we're trying to solve for x again. And this is like the questions in the previous section where we've got some constant terms on both sides. We've got terms with x's on both sides. And so we really want to get it so that all of the terms with x are on one side and all of the constants, all of the numbers are on the other side. Okay. And the other thing I notice here is we have 5 times 2x minus 3. So before we solve, I'm thinking it's going to be important that we try to expand this 5 times 2x minus 3. We could really interpret this as, you've probably seen questions like this before, 5 times 2x and 5 times minus 3. So if we wanted, five times 2x, well, that'll be 10x, and then 5 times minus 3 would be minus 15, plus 6. Okay, so we've got rid of the brackets by multiplying through like that. Now we'll collect like terms, just like in previous questions. I see nothing to collect there. And then on this side, there's nothing really to collect. Oh wait, 15 and 6. We could combine that. If we're at minus 15 and then we go up by 6, we would have minus 9. Okay, now we've got options. We could try to shift. We could try to shift our x's to this side, or we could shift our constants to this side. How about we move this 3x? So the opposite of minus 3x would be adding 3x. And then because I want to keep the equations equal, I'll do it to the other side as well. And that gives us minus 35 equals 13x minus 9. Opposite of minus 9 is plus 9. Minus 9 plus 9, those cancel. And again, to keep the equation equal, I'll add 9 to this side as well. And I end up with, oh, this is beautiful, minus 26 equals 13x divide by 13, divide by 13, whoa, minus 2, minus 26.